Hello, in this video I'm going to work through the first of the practice problems focusing on manipulating complex fractions. So without further ado, we'll look at the first problem here. And as the video about fractions shows, what we'd really like to do, one strategy for solving these would be to try to get the denominator equal to 1. We're going to get the denominator equal to 1 by multiplying by the reciprocal of the denominator. So right now we've got 16 over 5, so we're going to multiply the denominator by 5 over 16. But if we multiply the denominator, we have to multiply the numerator by the same thing, and we'd still have the 8 there. So now the next step would be what we have there. All of the things in the denominator cancel, so the denominator becomes 1. Then we have 8 times 5 over 16 in the numerator, or we can think of this as 8 over 1, if that helps. And when we multiply two fractions together, we would multiply those and we would get 40 over 16 over 1, or we might even see that 8 and 16 could cancel and we'd have 1 over 2 there. Either way that we get to this point, we would see that this is 40 over 16. 40 and 16 are both divisible by 8, so this would be 5 over 2, and 5 divided by 2 is 2.5. So 8 over 16 over 5 is ultimately equal to 2.5. And again, yes, I'll grant we could do this on a calculator, but the point, as we'll see later on, is to be able to work with the numbers and then extrapolate using logic to working with symbols so that we can solve complex chemistry problems doing that, where not everything is always numeric, but rather symbolic manipulation. Here we have 14 over 3. You might recognize right away from previous math classes that something that's in the numerator of the numerator could cancel something in the numerator of the denominator, in which case the 14s would cancel and we'd just be left with 1 over 3. But suppose we don't recognize that right away. We can still apply the same methodology of taking the denominator, multiplying by its reciprocal to get rid of the denominator or to turn it into 1. Here again, we'd have 14 over 1 in the numerator times 3 over 14 in the numerator because we've multiplied by something that's equal to 1. We're not changing this quantity, we're simply making it look different using these manipulations. Denominator, everything cancels, so the denominator becomes 1. 14 in the numerator cancels 14 in the denominator of the numerator, so those both become 1, and this becomes 3 over 1. 3 over 1 is itself 3, and then the denominator is still 1, but 3 divided by 1 is equal to 3. Next one down, we have 5 over 1 over x. We're going to use the same approach here, multiply by the reciprocal, so multiplying by x over 1, multiplying this by x over 1. Again, if it helps, you could remind yourself that the 5 is really 5 over 1, or you could just write it, I'll just write it as a big, and then we just have 5 times x over 1. Numerator becomes 5x, denominator becomes 1, and the answer here is simply 5x. Next one, 17 over 5 over 34 over 5. Same routine, 5 over 34, multiply the numerator by 5 over 34. 34's cancel, 5's cancel. Denominator is going to become 1. So notice, we focus on the denominator first, then we go up to the numerator. What's going on in the numerator? In the numerator, the 5's cancel. We have 17 over 34. The 17 cancels once. The 34 could be canceled to become 2. So the numerator becomes 1/2 over 1, or simply 1/2 or 0.5. Now, it might not be obvious to you immediately if I walk up to you on the street and say, what's 17 divided by 5 divided by 34 over 5? Half might not immediately leap into your mind. But, you know, if you want to, go ahead and take a calculator out now, calculate 17 over 5, calculate 34 over 5, divide by the 2, and then you'd get a half. Well, we can do all that just using what we know about simplifying fractions. And again, the point is that while this is entirely numeric, other problems might not be entirely numeric, like the one above, and we'll see one later on, where we need to solve for a particular variable when we're working a chemistry problem. So being able to rely on, what do I do with numbers? Oh, I can do the same thing with symbols, is the important thing to emphasize. Next one down. You know the routine now. Multiply by the reciprocal in the denominator. Now we have 1533 over 14 times 28 over 511. Denominator cancels again. It cancels because we make it cancel, and we do that by multiplying by the reciprocal, but anything we do to the denominator, we have to do to the numerator. That's the key thing in all of this, is that little, I was going to say trick, but it's not a trick, because in order to not change this quality, we can only multiply by 1. If we take 7 times 1, we haven't changed it. So this ratio is really just serving to multiply by 1, but in doing so, it's helping simplify the entire problem. Now we can see some cancellations. 14 and 28 would cancel, and we'd have 1 over 2. Now we might not immediately recognize it, but 1533 and 511 are also divisible into one another. The 511 goes into 1533 3 times. Now you might need to take out a calculator, so we could just say this is 1533 times 2 over 511, and that would be 1533 times 2 over 511, because the 1 in the denominator doesn't really affect the value. Anything divided by 1 is itself, so we just write it more simply this way. And then at this point, you would take out a calculator perhaps and go 1533 times 2, so you'd get 3066 divided by 511. And what you'd end up realizing that this really does divide 3 times, 511 does divide 3 times into 1533. So we really just get 3 times 2 over 1, so 6 over 1, or 6 as the answer here. So this whole thing is equal to 6. Very fancy way of asking for half a dozen eggs when you go to the grocery store. You know, do you have 1533 over 14 divided by 511 28 eggs? Oh, you mean a half a dozen? Yeah. So last one on this exercise sheet was 3x over 1 over x over 2y. So here we see a little bit more symbolic representation, but same idea. We're going to try to get that numerator, the denominator equal to 1. We do that by multiplying by the reciprocal. If we multiply the denominator by 2y over x, we have to multiply the numerator by that. Everything in the denominator cancels, so the denominator becomes 1. X cancels x. The 3 doesn't cancel, but the 1 x in the denominator of the numerator cancels the x in the numerator of the numerator. So then we have 3 times 2y, which is 6y. 1 times 1 is 1, so we get 6y over 1 over 1. So the numerator would be 6y over 1. The 1 here we'd stop writing it just like we did here. And then 6y over 1 again would simply be 6y. So it might not be immediately apparent, but this whole thing is equal to 6y. I'm going to look at that one again very quickly. So I'm just going to rewrite it, 3x over 1, x over 2y. And you might begin to, you probably have already keyed into something. You could save yourself a lot of steps now. Now that we've convinced ourselves that if we multiply by the reciprocal, the denominator always becomes 1. So in terms of being a more efficient problem solver, which is the expectation in general chemistry, in order to solve problems on exams quickly and have enough time to finish the exams. We don't expect you to be taking lots of time on algebraic steps that we expect you to know, and these are some of the algebraic manipulations you are expected to know by the time the first exam comes around. But what you see is, what we're really doing is taking and multiplying the numerator, and we can pretty much content ourselves that when we do that, the denominator is going to go away. So very easily we could say that this is going to be 6y over 1 or just 6y. So on future problems, like if we were, I'll just make one up. If we say 18 over 7 divided by 36 over 15, if I were solving this, I would say, okay, that's going to be 18 over 7 divided by 15 over 36. Because I know that the denominator is going to go away, I would say that that's 1 over 2, and we'd end up with 15 over 14. So I don't always go through all of the individual steps. I've been doing it here just to show the methodology. But once you once you see patterns developing, trust those patterns. If you know that they're right and you've convinced yourself that you're right, then you can become more proficient and more efficient at solving problems. So thanks for checking in. All of these answers are also posted on the answer sheet or somewhere on Blackboard. I haven't decided on the vehicle for that yet, but these will also be printed out somewhere. But I hope if you did not get these correct, that you revisit what you missed, understand why you missed it, and please, if you have any questions, please don't hesitate to reach out. Again, mark.vitha@drake.edu. And I hope this was helpful. Thank you very much. Have a good rest of your day. Bye.